Okay, so this is exercise 1 in the macros course. So this is just a exercise to sort of get us started in making macros. And here's the exercise. So hopefully you're familiar enough with ease to know that ease can build property plots for you. So here's one for air. This is the fluid air HA, and it's a TS diagram, and ease can put onto these plots the vapor dome as well as lines of constant, other properties like pressures or specific volumes. What this exercise asks you to do is build a macro with an ease program that automates the process of putting on this same kind of property plot a line of constant Joule-Thomson coefficient. So it's really just a way of getting some practice, but put a line of constant property on this plot that doesn't already exist. And the Joule-Thomson coefficient is kind of an interesting one. So in other words, here I might want to put a line of constant Joule-Thomson coefficient equal to 0, which is called the inversion curve, onto this plot, and you can see that's this green line right here. Everything to the left of this I think has a negative Joule-Thomson coefficient. Everything to the right has a positive one, and right along this line is 0, which means that if you went through a flow restriction, you would get no temperature change on that line. So that's the exercise, and to do this, you're going to have to automate the process of solving a table, making a property plot, overlaying the data in your table onto this plot, and so on and so forth. So it's an interesting one. It's not too bad, but a little bit sophisticated, and we'll give you some time to make an attempt at that, and then you can come back and we'll go through the process together. Okay, so the question asks us to overlay onto a property plot a line of constant JT coefficient. So the Joule-Thomson coefficient is just a property, so it's really just asking us to lay on top of it a contour of another property. So I guess maybe the first thing I'm going to do, just to get my bearings, is look at a TS diagram for some fluid like nitrogen. So here's property plot, TS diagram, nitrogen, like that, and we'll hit OK. And I think the way I'm going to do this is I am going to set a temperature, and then I'm going to try to find for that temperature, so along this line, the entropy at which the Joule-Thomson coefficient reaches some value that I set. And if I can do that at one temperature, then I ought to be able to do that at a whole bunch of temperatures, right down to the critical point. If I go below the critical point, I think it gets a little tricky because the Joule-Thomson coefficient isn't really defined inside the vapor dome. So we'll go from the critical point up to some temperature, and we'll do that in a table, and that's the part of the process that we will try to automate. All right, so let's see if I can just do that part. So if I'm going to use property functions in ease, I definitely want to set the unit system. So SI, mass, I always sort of use base SI system. I want to make sure I can do this at a certain temperature. So this is in Kelvin. Let's do it at 150 Kelvin. And I want to fix the Joule-Thomson coefficient. So the Joule-Thomson coefficient is what's the change in temperature that you get as a fluid changes pressure adiabatically, and sort of neglecting kinetic energy. So as you go through some flow restriction, it's dT/dP at constant H. So it's going to be in units of temperature per pressure. So maybe a reasonable set of units here is Kelvin per bar, right? If it's Kelvin per Pascal, it's going to be a tiny number. We'll do Kelvin per bar. So let's set it to something like 0.1 Kelvin per bar. And of course, this is not consistent with my unit system, so I need to convert this to the base SI equivalent. So mu JT K per bar times convert from Kelvin per bar to, here I have Kelvin per Pascal. Alright, and maybe we'll just solve that, make sure the units are all set. So that's got to be set. Everything looks good. So the last thing I got to do is try to find the entropy at which I get this Joule-Thomson coefficient. So if you have at least a recent version of these, you'll find that the Joule-Thomson coefficient is one of the functions that's built in here. So right here, Joule-Thomson coefficient. It comes up giving it temperature and pressure. I want to give it temperature and then entropy and have it find the entropy for me. So I'll go ahead and paste that in. Let's see, I probably want to set the fluid, and I'll use a string here, to nitrogen. I could then change it pretty easily. So down here this will be $, and I'm trying to find where this is equal to, I called it mu JT. So this is a complete set of equations. I would guess that without some reasonable starting point for entropy, I'm going to not be able to find this S. So let's go ahead and just try, maybe. So calculate, solve, and sure enough it doesn't converge. So I'll go back here. Actually, let's delete this one and make it again, this time in my base SI unit system. So nitrogen, TS, hit OK. So some reasonable values for entropy to look over would be sort of, this range in, let's say, 2,500 up to 6,000 or 5,800, right in there, right? I know it's going to lie sort of right in there. So let's get rid of this, and we will set limits for entropy, and I can either do that in the variable information window. I tend to like to do it right here at the top using a $var_info command, just so I can see it and change it real easily. So I have this variable called S, and I want to set the lower limit. So I think that's lower. If I'm not sure what it is, I can go to the directive information window and figure it out, but I'm pretty sure it's lower, so I'll go ahead and put that at 2,500. Upper is going to be 5,800, and then guess will be 4,200, somewhere in the middle, something like that. And I think that now, if I solve, I'll get a solution. So 4155, that seems reasonable, and it's in joules per kilogram Kelvin. Alright, so at one temperature, I can find the entropy that gives me a specified Joule-Thomson coefficient. So if I can do it at one temperature, hopefully I can do it at a whole range of temperatures. And this is where I'm going to start to build a macro to do this automatically for me. So I can either select macro window here, this M on my speed bar, or if I want to, I'll just go to new macro. So there's my macro. Let's see, I'm going to record the commands that I want to automate, just so I don't have to go look up what the macro commands are. So this is recording now. The first thing I'm going to want to do is make a parametric table. So new parametric table, we'll put S and T in it. There's 10 runs. That seems fine. Maybe we'll call it something a little better, like JT coefficient, and hit add and OK. And there's my macro command. So this builds this table. Next thing I want to do is vary the temperature. So let's go from, I don't know, 130 Kelvin is just above the critical point, to 250 Kelvin, and hit OK. And there it is. If I want to adjust these temperatures, I can just go in here and change them. Probably the next thing I want to do is actually solve the table. So calculate solve table. And these are my entropies that I need to overlay onto my property plot. So that looks good. We could probably stop here and just make sure this works every time I hit the play button. So play. Yeah, it ran. You can see that down here the log is showing that it ran. If I go look at my parametric table, it built another parametric table. So that's a problem, is every time I run this, apparently it's going to build a new parametric table for me. So Probably the first thing I want to do actually up here is delete the parametric table. So I think if I go look in my command list here under tables, parametric tables, delete parametric is the one I want, and we'll put that in here. So basically this is going to say if there is a parametric table called JT coefficient, get rid of it so that I can make it again. So let's get rid of these, and we'll try to run this again, and hopefully I have a parametric table now. Sure enough. Okay, so that seems to work, and if I run it again, I still just have one parametric table, which is what I'm after. Alright, so what's the next thing? The next thing is let's go ahead and build a property plot. So here's my property plot. I want to do this for nitrogen. These are probably okay. Maybe we'll go from 65 to, I think my temperature range went to 250, so 250. Maybe we'll call this something else like prop plot and hit OK. And there's my property plot. And oh, I forgot to turn recording on, so let's get rid of this and do it again. This time let's actually record the macro commands that do that. So here's recording. I don't want to optimize. Property plot, nitrogen TS diagram 65 to 250, and we're going to call this prop plot, and we'll hit OK. And there it is. So now it'll make that plot. And then the last thing is let's overlay our states onto this plot. So I'm still recording, so this should get recorded. So plots, overlay plot. Let's see, x-axis is S, the y-axis is T. Maybe I don't want symbols and I just want to make this a big, thick green line like that, and we'll hit OK. And there's my line of constant JT coefficient. Right. So let's turn this off. And I'm not recording anymore. I should just be able to play this. And every time I play it, I should get the plot with my line of constant JT coefficient on it. If I make the JT coefficient different, so I don't know, maybe we'll double it, I should see that this line moves. Let's run it again. And yeah, sure enough, it moved over to the left a little, or the right a little bit. Alright, I mean, I can do some other things here to make this look better. I can add some labels. Maybe let's go ahead and do that. So if I go to my show macro commands, so this is my macro command information dialog, and I go to plots again, I think one of the commands I can use is add plot text, like that. So let's copy that here. So add plot text, the name of the plot is I think prop plot. These are plot, so this is the x and y position on the plot, so not the coordinates, but rather just 0 to 1 and 0 to 1, I think. So x would be maybe 0.1, y 0.9. That should put it up in the upper left corner. The text, you know, this is interesting. We'll come back to this in a second. Let's call this label $, and we'll build a string label $. 16 points is going to be way too small. I think we'll make it 36. And then I want it to be a legend. So this is just saying which of these data series do I want this legend assigned to. And you got to be a little careful here because there's a whole bunch of data series on this plot. So if I right click on this plot, I'll find that it's 19 is the one that I did. So we'll make this legend for 19. Alright, so let's build our text here, label $. Label $, is going to be, let's see, I guess maybe something that says JT coefficient equals whatever I set it to, and then the units, right? So the first thing I want to do is get a string that corresponds to the number that I set the JT coefficient to. So I set it to this number right here, 0.2, but that's not a string, so I think there's a command. I'm sure there is. If I go to options, function information, one of the categories here is strings. I want to use the function, I think it's string dollar right here. So string dollar takes a number and turns it into a string. So this is going to be equal to string dollar mu jt in k per bar. I think that's true. And this will just put up that number. So let's run this, make sure it works. Yeah, 0.2. So that's not super descriptive, but at least it puts it up here. If I want to make this a little more descriptive, maybe I'll do a little better here. And I will concatenate this string with another couple strings. So let's call this label $1 is equal to, I think it's concat dollar. And here I put the two strings I want to concatenate. So the first one would be something like, I don't know, JT coefficient equals, and the second one would be label dollar. And maybe I want to do another one, label $2, which is concat label $1, and then I'll put the units. So Kelvin per bar, something like that. And then what I want to put on here is actually label $2. So hopefully that all works. And we will play it. And it didn't work. What didn't work here? So let's go down here. String label dollar. This should be label $1, I think, in Kelvin per bar. Yeah, and this should be, oh, I see why. This is concat dollar. Any function that returns a string has a dollar there. So I'm going to save this and try it again. There's my line, and yeah, the line is JT coefficient is 0.2 Kelvin per bar. So I think hopefully you can see how useful this is. If I want to put a different JT coefficient line on here, like, I don't know, 0.1, I just change it there, run it again, and now I get my plot, but with a different 0.1. If I make this 0, I'll get the Joule-Thomson inversion curve. If I make it negative, I'll go probably farther to the left. If I wanted to make this work for other fluids, it's probably going to take a little more effort, because I'm going to find that these guess values for entropy aren't probably valid for different fluids depending on their reference states. And also this range of temperatures right here that I used to set up my parametric table probably aren't quite right, so I'd have to go in and make those specific to whatever fluid I was using. But hopefully you can see the value of making a macro to do something that would otherwise be kind of tedious and you might want to do over and over again.